Hi everyone and welcome to Autodesk PowerMill. So we are going to start a new video which is all about the introduction to 5-axis machining. And in this video we are going to cover understanding 5-axis movements, list area clearance, plate finishing, hub finishing, and bar cutting operation. So before going to start the 5-axis, we should have to understand the 5-axis movements. So through this picture, you are going to understand the 5-axis movement. So in the previous sessions, we just discussed about 3-axis movement, where we have the X, Y, and Z movements. And most of the time, we have Z-axis movement, the downward direction, to set up the depth of cuts. But these 3 types of movement are able to create the geometries, or we can say that 3D geometries. But some of time, we get the geometries which are very complex and where our tool is not going to be worked. So we need some extra axis so that we can rotate our tool or rotate our workpiece at certain degree or at certain angle so that we can machine that area. As you see in the picture, the head of the Z-axis is being tilted at certain degree. So this is what we call the B-axis, and it's rotating in the positive direction. And the purpose of rotating the axis at certain angle is to get the tool to be positioned at certain position where our tool is not being covered that machining area. For example, if you have a part where you have to reach that tool, like the part with the undercuts, so that part is going to be machined using the other axis like 5-axis machining. So we have 5-axis movement as X, Y, and Z. These are 3 axes. Then we have further 2 axes, which are mostly be used as A-axis and B-axis. But according to the machines, we have different abbreviations for that. Some machines uses the A and B axis. Some uses the A and C axis. Some machines use the B and C axis. So it depends upon the machine which tool is going to be set it on the machine. So in the picture, you see that it's represented as X, Y, Z, and then B and C axis. The C axis rotation is being shown where our workpiece is being placed on a table. So the table is going to be rotated at 360 degrees. It should be rotated either in the clockwise direction or either in the anti-clockwise direction. But if we talk about the B axis, the spindle rotation or tilting position of the spindle is being set it as B axis. So let's go and cover up the 5-axis machining operation. What we have to do is we have to study about the first operation, which is called the list area clearance. So let's get started the list area. So I have been using the Autodesk PowerMill ultimate, and in this PowerMill, you will find out that there is an operation known as list area clearance. So by the way, we have to load the model first by clicking on the board model, go to the examples. You will find out the 5-axis operations or 5-axis files for your exercises. So if we go and click on the list, simple, because we have to perform list related operations, and we have a file which is named as list_simple.dgk file. That file is being mostly used by the CAM geometry, but right now we have an Autodesk, so these files are here. But you can easily or simply import them. Click on that thing, use the open option, and it's going to be open. So you have to zoom out because this file is a very huge file. You see that it's a turbine. You will find out blades, you will find out the hub. So what we call it, this is the hub, and these are the blades on that hub is placed. Then we have a shroud, and the purpose of shroud is to align your turbine blade, give them support. So it's a part of our turbine, and we have to machine it using the bliss operation. So certain this operation is going to be specialized design for such type of examples you have, or such type of application. So if you load this part, you will get the levels and sets of it being defined. So talk about the main model, if you talk about the shroud, you can hide it shroud like that. This thing is being created in the levels set. So already being set. If we talk about the right side blade, you see that this is the right side blade. So for using the bliss operation, you have to set up the levels. Here we have the left blade. This is what we have, the hub. And this is the main model. So let's go and apply the bliss operation. So I'm just going to hide out the shroud. So first thing what we have to do is we have to set up the block or the stock material. So as you see that it's a cylindrical type part, so we have to set up the cylindrical part, cylindrical stock. So I just set the cylinder, click on the calculate, and it's going out calculate the exact size for the model. Go and click on the exact and it's done. Now it's starting to apply the toolpath. We can set up all other things like tools and boundaries in the toolpath. So just go and click on the toolbar and find out the bliss operations. So we have covered the 3D area clearance, we have covered the curve, we have covered the finishing operations. Now it's time to discuss about the blisses. So when you go and click on the bliss, you will find out that we have blade finishing, we have bliss area clearance, we have hub finishing, and then we have a single blade finishing operation. So the first operation we are going to discuss about the bliss area clearance. You see that the diagram is going to be shown how it's going to be worked. So just go and click on it. You will find out the bliss area parameters are being opened. We have a work plane. We set it as just define work plane by the global. We don't make it any work plane to be active. Model at which is being created, the already work plane is being here. We have set it up the block already. Now it's time to set up the tool. But before setting up the tool, you have to write the name of the operation, which is bliss operation. Bliss area clearance. So what we have to do is we have to clear the area between the blades. So this is what we call the area clearance. If we are going to perform the finishing operation, that would be easily done. But thing is that we have to remove the area. So first of all, let me show you in simple that if we have to perform the clearance, then it will be very much easy. Just go to the bliss area clearance operation and define the bliss. So already we have created the levels and set. So make sure that you have to set up the levels. Go and click on the hub. It's going to define the hub. This is one in the hub. Go and select the shroud. Select the plates. We all want to set up the finish. We don't have an finish level. Just leave it. Go and select the left plate, select the right plate. So we have to machine one plate right now. Yes. Make the tolerance level 0.01. Set up the tools. So let's go and define the tool over here. Now we have to set up the balls. I'll go and set up 15 millimeter balls mill. 15, set up the length. It can be length about 150. So as you see that your part is very close, your blades are very close. So what you have to do is you have to use a suitable tool holder for this operation. Otherwise, your tool holder may collide with the blades. So you have to use a conical and different diameter tool holder, the long shaft, so that it will be able to hold all the tool and machine. So there are some tools which are very lengthy, like which you see that I have set it the length as 150 millimeters. So you have to set it tool according to the geometry. So let's go and click on the list. We have defined the definitions. We have the blade set up it over here. It set up the step over distance. Go and set up the distance 7.5. Make it like 10 millimeters. Go and set up the step down. So for the example, I have to set up the step down. Just for the sake of example, let me see that I'll go and set up the step down 5.0. That's a very huge depth of cut, but just for to check the exact toolpath values. When the toolpath values are going to be turned, then we can go and set up all these things later according to our tool and geometry specifications or material specifications. So we go and set up the machining strategies after later because it's going to be done as a finishing operation. So let's go and click on the leads and leading links. And go and set up the leading and links with the straight, make it scale. I just uncheck, check. I will not go to speed and speeds. I'm not going to change anything because it's just for the testing purpose. So just go and click calculate, and it's going to calculate the operation. And you see that it's going to cut all the material between the surface of two blades. So if you want to show you how it's going to be, you can go and click on the simulation, check the base area. So I'm going to play that one, and you see that the cutter is going to move in a 5-axis direction movement. It's going to cut all the material, and ensuring that the cutter is not going to collide with the blades. It's going to follow the geometry as well. So that's what we call the bliss area clearance, but it's a finishing operation. We have to ensure to perform the best area clearance operation. What we have to do is we have to do certain things. So if I go and click on the tool view, preview it, so you see that it's going to rotate in a certain way. You go to beginning, and you see that this is like how the tool is going to perform, and you see that the rotation of the workpiece, the rotation of the tool, the degrees and angles, all is being done. That's what we call the bliss finishing. Let me show you how we can go and set up the roughing operation, because we have a lot of material between these two blades. And how we can do is just go and click on the machining, and then we have to set up the cut direction and adding. This may actually rotate the fractions in a zigzag way, and then should be the climb and convention both. Set up the offsets, because we have to set up the offset up. We have different options, type of offset down, offset up, or merge. In the merge, it's going to take up the offset up and offset down both way. Now we're going to take the offset up. This means that it's going to take this path and make it in an upward direction and move down the material. So this way it's going to take a lot of cuts and to move the material, just like in the finishing pattern or finishing pattern toolpath. Just go and click on the calculate. It's going to calculate the all material between the surfaces. So it will take some time. What you have to do is you have to wait for the calculation is going to be done. Sometimes it's going to tell you that the material is not going to be removed because we didn't have to create the machining region or machining setup or level setup for the fillets. So you see that there are fillets around that blades. So we didn't create any level for that. If you go and create that level, the type of files are going to be not shown to you. So let's wait for the operation is going to be fully calculated. And you see that it's going to take down all the material between the two blades. That's what we call the roughing operation, and that's actually the area clearance or basic area clearance. Now let's go and play that thing. Drawing this. Okay. Just how it's going to remove that material. So it will take some time to complete it, because we have to set up certain things. So one by one, it's going to take this step down and cut out the material different area, ensuring that there is no lodges between them. It's almost 100% completed. You can go and increase the speed so that we move material fast. So this is the one operation you have performed it right now in between the two blades. So we have 18 blades on it. So what we have to do is go and click on the place clearance. You see that it's between the one blade. So you can go and click on calculate. See that's going to calculate the blades. Total blades we have 80. So now this tool path is going to be patterned or circular pattern, or we can say that we copy of all these things around all these blades. As this type of operation is already being set it up over here, so that it will be very much easy. And you can go and create also the copy of all these tool paths around this circuit geometry. If you go and calculate it, all these operation is going to be applied on these 18 blades. So it will take some time. Just go and click calculate. Okay. So the machine one blade, we have to machine all blades. Okay. Calculate it, and now it's going to calculate. So it will take some time to calculate the operation. We have to wait. So you see that all the toolpath is going to apply on these all 18 blades, and that's how it looks like the blissed area clips. So it's simple and easy. There is no such difficulties being shown in the toolpath. What you have to do is you have to insert the fitting toolpaths and all this stuff. Okay. So that's it for the multi-axis, and that's it for the blissed area clips. Hope you like it. Thank you very much.